Today, we're tackling a big one. What actually powers the stars, specifically our sun. You've basically got two main camps, right? There's the standard solar model, it's the one you usually hear about,
Yeah.
gravity, nuclear fusion, a giant reactor.
Right, self-contained. And then there's the, let's say, challenger, the electric universe idea.
Yeah, totally different. Stars lit up by huge currents flowing through space. Seems like you can't really have both.
They do seem pretty mutually exclusive, generally speaking.
Exactly. But that's our mission today for you, a thought experiment. Could we maybe build a sort of hybrid, let's call it core nuclear, surface electric, CNSE?
Taking the strong points from each.
Interesting. Yeah, what could we learn by trying to bridge that gap?
Let's see. So the standard model first, that relies on fusion deep down.
Absolutely. Extreme gravity in the core, squeezes hydrogen plasma, fuses it, and bam, mass converts to energy, huge amounts of it.
And we know this partly because of neutrinos. Precisely. Solar neutrinos. Tiny particles born right in those fusion reactions. They're like direct messengers from the core.
Yeah.
But initially, there was a hitch, the solar neutrino problem. We just weren't detecting as many as the theory predicted.
Ah, okay. So people challenging the standard model, the electric universe folks, they must have jumped on that.
Oh, definitely. They pointed to it and said, see, told you there's no fusion. It looked like, well, pretty strong evidence against the standard view at the time.
But science didn't stop there, did it?
Not at all. This is where it gets really fascinating. Scientists figured out something called neutrino oscillation.
Oscillation, meaning they change.
Exactly. They switch between different types or flavors as they travel from the sun.
Yeah.
So the missing ones weren't really missing. They just changed into a flavor our detectors weren't initially looking for.
Wow. So finding that didn't just solve the problem.
It became a massive confirmation of the standard solar model and a fundamental discovery in quantum mechanics, too. You pretty much closed the book on that specific no fusion argument.
Okay, so the nuclear core seems solid. Undeniable, really. But the standard model isn't perfect, right? There's still that weird thing with the corona.
The coronal heating problem, yeah, that's a big one. The sun's surface, the part we see, is around, what, 500 Kelvin?
Roughly, yeah. Hot, but not crazy hot.
But the corona, the atmosphere way above it, is over 1,000,000 degrees Kelvin. Maybe 2 million in places.
Which makes no sense thermodynamically. Heat shouldn't flow outward from cooler to hotter.
Exactly. It's a real puzzle.
So how does our hybrid CNSE idea try to tackle that for you?
Well, it suggests the core fusion energy is still the ultimate driver. That energy stirs up the sun's interior, the convection zone, huge boiling motions.
Like a giant pot of soup?
Sort of, yeah.
Huh.
And those motions drive the sun's magnetic dynamo. Generates incredibly powerful, complex magnetic fields that reach way out into the atmosphere.
Okay, so magnetic fields, how does that lead to heat?
Think of tangled magnetic field lines storing enormous energy, like stretching rubber bands. Eventually, they snap and reconfigure. It's called magnetic reconnection. That sudden snap releases a huge amount of energy, explosively heating the plasma in the corona to those insane temperatures.
Ah, so the heat isn't flowing directly from the surface. It's magnetic energy released way up high doing the heating.
Precisely. It's a surface electric phenomenon involving magnetic fields and currents, but it's fundamentally powered by the nuclear furnace down below.
That connects the dots quite neatly, but it's still rooted in the sun's own energy, not power coming from outside.
Absolutely critical distinction. The CNSE idea isn't reviving the externally powered star bit from the electric universe theory. It's saying the sun itself generates these powerful electrical effects on its surface and atmosphere. And, mainstream physics actually supports parts of this. Calculations show the sun has a small net positive charge, maybe 77 coulombs or so, because lighter electrons escape its gravity easier than protons.
77 coulombs doesn't sound like much for the sun.
It's small, relatively, but it's significant. And we also observe the heliospheric current sheet, this massive, sort of wavy structure extending billions of miles out.
The ballerina skirt thing.
That's the one. It carries a colossal current, about 3 billion amperes.
Whoa!
But again, in the CNSE view, this isn't electricity feeding the sun. It's the sun's own energy system, creating an outflow, defining its sphere of influence electrically.
So the sun is a nuclear furnace and a giant electrical generator, basically. Its own internal processes creating these vast external currents. That's a different picture for you.
It is, and it might add some nuance elsewhere, too.
Right.
Like planetary orbits.
Right.
Gravity is king there, obviously.
Right, ellipses and all that, Kepler, Newton.
Sure. But could this electrically active environment, the solar wind, the current sheet, could it maybe play a small secondary role? sort of modulating things slightly. It's a possibility.
Interesting. And what about, this might seem out there, but things like the golden ratio appearing in space, sometimes tied to sacred geometry?
Ah, yes. Well, maybe the CNSE perspective offers a different angle there, too, instead of something mystical. What if it's just physics? Plasma dynamics, the way currents behave, can naturally form spirals and helical shapes. Think of Z-pinches in filaments.
Like lightning, how it branches and constricts.
Exactly like that. So if these electrodynamic systems naturally favor certain geometries, maybe the golden ratio isn't sacred, but an emergent property of the physics itself, everywhere in the cosmos.
Wow, okay. Turning perceived mysticism into potentially observable plasma physics. That's quite a shift in perspective for you to consider. So wrapping this up for you, this core nuclear surface electric model, this thought experiment, it paints a richer picture, doesn't it?
I think so. A nuclear heart, yes, but wrapped in this dynamic, electrically buzzing outer layer.
The key insight really is the synergy. It's not either. The nuclear and electric aspects work together, driven by that core engine. It feels more complete.
And it's testable, too. We're not just hand-waving here. Missions like the Parker Solar Probe were flying right through that corona.
Written direct measurements.
Exactly. Measuring the fields, the particles, the energy transfer. That data will be crucial to see how well these ideas hold up. How does the sun's internal churning connect to, say, the strengths of that huge current sheet?
Fascinating stuff to watch. So maybe the final thought for you is this image, a star powered by this incredible dance between fusion fire deep inside and electromagnetic energy raging on its surface. A cosmic synergy, something to really chew on.